Hi, this is Algebra 2, Lesson 22. We're going to talk about uniform motion problems with equal distances and similar triangles and proportions. We're starting on page 104. Doing uniform motion problems helps prepare you to do more complicated problems in physics and chemistry. You may never have to figure out when trains pass each other in the night in real life, but these skills will be useful in higher maths and sciences. Really. Uniform motion problems involve statements about people or things that move at a constant speed, or more realistically, at an average speed. When you get to physics, we're going to learn that there's a difference between speed and velocity, but your book is going to use the terms interchangeably in this course. The problems we're going to work on will contain 4 statements about things that are equal or differ by a given amount. Each statement can be turned into an equation. The key to doing these is to remember that rate times time equals distance. The book uses diagrams to help illustrate the problems. Just as in the percentage problems, you are not required to make the diagrams. But if you have trouble setting up these kinds of equations, try the diagrams. They are a tool to help you. Okay? So if 2 people or vehicles travel the same distance, the diagrams are going to look like one of these. We have distance 1, so the first person went from this distance to this distance at a certain rate or time, and then another person or vehicle went the same distance at a different rate or time. Okay, or we have one person who started here and went this way, and then they went from here back home again. Okay, in both cases, D1 equals D2, because both cases they're going the same distance, and because distance equals rate times time, that means that rate 1 times 1 time 1 equals rate 2 times time 2. Okay? So here are some examples. Roger made the trip on Sunday, and Judy made the same trip on Monday. Roger traveled at 12 miles per hour. Judy traveled at 12 miles per hour, and so her time was 2 hours less than Roger's. How far did they travel? So they took the same trip, which means they traveled the same distance. So if we draw the diagram, they're going the same distance. Here's the distance of Roger, and here's the distance of Judy. They're starting at the same place, and they're ending at the same place. So the distance of Roger equals the distance of Judy. Okay? So we can say that the rate of Roger times the time of Roger equals the rate of Judy times the time of Judy. It tells us that Roger traveled at 12 miles an hour. Roger's rate is 12. Judy traveled at 20 miles an hour. The rate of Judy equals 20. Her time was 2 hours less than Roger's. So the time of Judy equals 2 plus the time of Roger's. Or we could say the time of Judy minus 2 equals the time of Roger's. Those would be equivalent statements. Oh no, that's wrong. Sorry, I did that backwards. It's the time of Roger's minus 2, because her time is shorter. So we could say the time of Judy plus 2 equals the time of Roger, or we can say the time of Judy equals the time of Roger minus 2. Sorry about that. We can substitute the values for these rates into the distance formulas and substitute TR minus 2 for time of Judy. Okay? So we have the rate of Roger is 12 times the time of Roger which equals the rate of Judy, which equals 20, times the time of Roger minus 2. And now we can solve for the time of Roger. So we have 12 time of Roger equals 20 time of Roger minus 20 times 2 is 40. Okay, can move this guy over here. So now we have 12 times the time of Roger minus 20 times the time of Roger, which is minus 8 times the time of Roger equals negative 40. Divide both sides by negative 8. And the time of Roger equals 5, and we're in miles per hour, so this is hours. Okay? If the time of Roger is 5 hours, then the time of Judy is 5 hours minus 2, so the time of Judy is 3 hours. Okay? What the problem actually asks for is how far did they travel? We're going to check our work by solving it for both sides. So the distance of Roger is the rate of Roger times the time of Roger. So that's 12 times 5. And if we did this right, that should equal the rate of Judy, which is 20, times the time of Judy, which is 3. So this is going to show us the distance they traveled and check our work. 12 times 5 is 60. And 20 times 3 is also 60. So this is a true statement, which means we did our work correctly, and the distance they traveled was 60 miles. Okay? Use your units and circle your answers so I can find it. Alright, let's try another one. Brer Rabbit, that means brother, Brer Rabbit hopped off towards the briar patch at 10 kilometers per hour at 10 a.m. At noon, Brer Wolf began the chase from the same starting point. If he caught Brer Rabbit at 2 p.m., how fast did he run? So in the end, we want to know the rate of the wolf. Okay, they're running from the same starting point, and they're ending at the same place where the wolf catches the rabbit. So if we draw the diagrams, we're starting from the same place, we're ending from the same place. So the distance of the wolf is going to equal the distance of the rabbit. The rate of the rabbit times the time of the rabbit equals the rate of the wolf times the time of the wolf. We know that the time of the rabbit is from 10 o'clock until 2 o'clock, so that's 4 hours. The time of the rabbit is 4 hours. The time of the wolf started at noon. So the time of the wolf is 2 hours. And we know the rate of the rabbit is 10 kilometers per hour. So we can substitute all these into the beginning formula and solve for the rate of the wolf. So we have the rate of the rabbit is 10, the time of the rabbit is 4, the rate of the wolf is what we don't know, and the time of the wolf is 2. Okay, so 40 equals 2 times the rate of the wolf divided by 2, and the rate of the wolf is 20, and we're in kilometers per hour. Okay? That was a nice one because we didn't have to do any crazy substitution. It was all very straightforward. Similar triangles and proportions. We can find the corresponding sides of similar triangles without using the scale factor by setting the ratios of the proportional sides equal to each other and then cross multiplying. So here we have two triangles. We see that this angle is equal to this angle, and this angle is equal to this angle, and we learned that if two angles are equal, then the third angle is also equal. So this angle equals this angle. So the triangles are similar. Because they're similar, That means the ratios, the proportions between the sides are also equal. So 9 is to 7 as x is to 5 as y is to 8. Okay? So we could go from either left to right or right to left. Just for fun, this time we'll go from right to left. So this side corresponds to this angle, which means this side corresponds to this angle. So we have 9 over 7. This angle corresponds to this side, and this angle corresponds to this side. So we have x over 5. And this angle corresponds with this side, and this angle corresponds with this side. We have y over 8. We could have done it the other way. We could have said 7/9 is proportional to 5 over x, which is proportional to 8 over y. Both of these are true. You just need to make sure you're going the same way for all three sides. So we can't say 9 and 7 and 5 over x. We have to go from the same direction all three times. Okay, so now we can set these ratios equal to each other. And remember, that's what a proportion is. It is ratios that have been set equal to each other. So 9/7 equals x over 5. And 9/7 also equals y over 8. And now we can cross multiply and solve for x and y. So we have 9 times 5 is 45, which equals 7 times x. We'll divide both sides by 7. And we get x equals 45/7. And there's nothing we can do to simplify that. Okay, over here we have 7 times y equals 9 times 8, which is 72. Divide both sides by 7. And we have y equals 72/7. And then, once again, there's nothing we can do to simplify that. Okay, that's it for these problems. Make sure you find the corresponding sides. You can go from left to right or right to left, or go back and forth, as long as you are using all of them from either right to left or all of them from left to right. Don't mix-match them. Okay, that's it. Let me know if you have any questions. Try your practice problems, and that's it. Thanks.